In fact, they both diverge to infinity, given the conditions here. Oscillation is not possible because we have series with positive or non-negative terms, right? How do you prove this? You can just look at the nth partial sums, right? And use basically the squeeze theorem on nth partial sums. I don't think I'm going to write it out. I'm going to spend my time on the other one, which is less obvious. This is obvious. I mean, if you look at the nth partial sums, the proof here is it's really quite easy. So the other, and well, I guess you guys want an example. I don't know. Maybe you don't. Let's see here. So the other one, the limit comparison test. Limit comparison test, or sometimes this is called LCT, is what? Well, if you have, again, series with, this time series with positive terms, and if a sub k over b sub k goes to L, where L is what? L is a positive number, positive real number, then the sum over a sub k converges if and only if the sum over b sub k converges. So this is greater than 0. Then this theorem right here, this is really something. I'll probably start tomorrow for you guys with a proof of this. I want to give you just a brief example of it for now. What's the example? How about this? If you look at the sum, one over the square root of n, k rather, k equals 1 to infinity. And if you look at the sum of 1 over, I don't know, the square root of k plus, well, let's say 13k plus 7. This isn't the most powerful example I can think of, but maybe it's a decent one. Clearly both positive terms, right? Here's your a sub k, here's your b sub k. What's the fraction a sub k over b sub k is equal to what? Which is what? That's the square root of 13 plus 7 over k. This goes to the square root of 13, right? So, by the limit comparison test, we have that the sum k equals 1 to infinity of 1 over the square root of 13k plus 7 diverges since the sum of 1 over the square root of k equals 1 to infinity diverges. How do we know that that diverges? Well, we just proved it over here, right? This is a very powerful test. This is extremely useful for comparing things that you really don't want to tinker with directly, to something that's easy to tinker with directly. Like this is pretty easy to tinker with directly, right? So the more things like this you know, you can use those to kind of jump off and analyze things that are like uglier. But you know, you look at it, it's ugly, right? But it's basically square root of k, you know, with some noise. Well, if you get a sheet of paper out, put your name on there. Put away your other stuff. And I will just ask you to define for me define what it means to have a convergent series. All right? And also define its sum. Oh, seems I'm getting behind with you guys. Man, I hate that this was the most unfortunate event today. I'm sorry about that.